Today we're going to discuss a unique problem which can help us understand probability slightly better. The question is that what is the maximum number of tickets that can be printed? Now we're talking about a lottery ticket which is made up of 5 different numbers. Now in the lottery ticket these 5 numbers can be between 0 and 9. So let's assume that we have our lottery ticket, and in this lottery ticket we have 1, 2, 3, 4, and 5 numbers that we need to have. Now these numbers can be anything from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now when I go to the first digit, I have an option of picking any one of these numbers. And I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 options. That means for the first digit I have 10 choices. Now when it comes to the second digit, I don't have any rules that prevent me from not using the same numbers again. So I will have 10 options for the second digit. I will have 10 options for the third, fourth, and fifth. Now you have to multiply 10 times 10 times 10 in order to see what's the total number of tickets that are possible. Now this is not exactly probability because first we're doing combination, so you do have to keep this in mind, and what I'm explaining only applies to this question. So 10 times 10 times 10 times 10 is 100,000. That means if I have a lottery ticket which is made up of 5 numbers that are between 0 and 9, I can have 100,000 tickets. Now we have a second scenario here. It says in the lottery ticket none of the numbers can be repeated. Okay, so we have another lottery ticket in our hand, and in this lottery ticket we're going to have 1, 2, 3, 4, and 5 numbers. Now the rule here slightly changes. We cannot repeat any of the numbers. I still have between 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 to pick. So when I go to the first digit, I have exactly 10 choices that I can use. Now it says none of the digits can be repeated. So when I go to the second place, let's just say on the first digit I have used, let's use red for the lottery numbers. So let's just have used 8. Now I can't repeat 8. That means here in the second choice, when I come to the second digit, now I have how many choices? 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I get to the second number, I have 9 choices. Now, for instance, let's just say for the second digit we used up 3. Now remember, none of the digits can be repeated. So now when I get to the third place, I have 8 choices if you count correctly. Now let's just say for the third digit we picked 5. Remember, none of the digits can be repeated, so I can't repeat 3, I can't repeat 5, I can't repeat 8. Now that means for my fourth number, I have to have 7 choices, and then for my fifth, I'll have 6 choices. So in order to figure out how many tickets can we print with this combination, we have to multiply 10 times 9 times 8 times 7 times 6. Whatever we get from multiplying this is the total number of tickets we can have. Now 10 times 9 is 90. 90 times 8 is 720. 720 times 7 is 5040. 5040 times 6, I believe, is 30,240. Now notice something. When we had the rule that we can use any digit anywhere, we were able to print 100,000 tickets. Now that our rule has changed and it says none of the digits can be repeated, we were able to print 30,240. Now let's consider a third scenario. In the third scenario, it says none of the consecutive digits can be the same. Let's draw our lottery ticket, Again, we have 1, 2, 3, 4, 5 slots. Now, it says none of the consecutive. So keyword consecutive. What does consecutive mean? Next to each other. That means whatever I put here, I cannot put here. Okay, so again, we'll use red for the number that we pretend that's actually on the lottery ticket, and black is the number of choices we have. Okay, so please don't get confused by that. The number on top tells me how many choices do I have for this position, this position, this position, and the number on bottom that I'm writing is just for our sake, just so we can see a live example of what it could be. Now, when we get to the first digit, you should understand that we have no restriction because we haven't used any of the numbers, so I would have 10 choices. Now let's just say out of these numbers, let's just say we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's just say that we decided to use 7 as the first digit, okay? So we're using 7 here, so we got to cross 7 out. And that means in this position, the second position, I can no longer write 7. So how many options do we have? If you said 9, that would be absolutely correct. We do have 9 choices when it gets to the second one. Now it gets interesting when it gets to the third slot. What happens when we get to the third slot? Remember, we have 9 choices for the second because we have used up 1 here, so now I have 9 left. Now let's just say I have used 2 here. Okay, so 2 is gone. Now we're in the third slot. We have to figure out what digit can we put in the third slot. Now when we get to the third slot, I can use any of these numbers except 2. As a result, how many choices do we have for the third choice? If you count out and you said 9, you would be absolutely correct. When we get to the fourth slot, again, let's just say for the third slot we used up 4. So 4 is gone. Now remember, when it comes to the fifth slot, I can use any digit except 4. So how many options does that leave me with? That leaves me with 9 options. And for the fifth slot is the same scenario. So the product of 10 times 9 times 9 times 9 times 9 is going to be the number of tickets that we can get from printing and by following these rules. So let's do the product really quick. I believe when you multiply 10 times 9 times 9 times 9, you get 65,610. I hope this was a little bit insightful into the problems we tried yesterday. And if it's still not clear, feel free to ask questions and we will be reviewing multiple problems like this.